everyone, and welcome to G Nation 2020. My name is Samuel Santos, and I will be your host for of the day. Hi, Lili. Thank you for being with us. It's a pleasure to have you. Hope you are well in these difficult times. So I don't want to delay you anymore. Are you ready to start?
Yes, absolutely.
Okay, over to you. Thank you.
Thank you. Working in a fast-paced environment can be very challenging. Customers are demanding new features in a timely manner. The support team are waiting on those bug fixes. And on top of it all, there is always tech debt to address and legacy code to maintain and refactor. Keeping it all running smoothly can feel like a game of Jenga, where if the first few moves left the tower with a wobbly foundation, adding or removing any new blocks could completely collapse the tower at any moment. In engineering, it is important to have a strong foundation, so you can move fast and continuously deliver value to customers. We want to be able to add new features without breaking any existing functionality. But this could be a challenge, especially if that feature or a fix is in that legacy piece of code that we all avoid touching too much. This is where having really good tests can help you out and make you feel confident with every push to production. But what do you do if over time those tests became outdated, have some gaps, or simply don't cover enough of your core business flows for you to rely on them? This is where we've turned to TypeScript as one of the tools to help us. But making big changes across an organization can be really difficult. At the time, we were 8 separate teams, and we follow a microservice architecture. So we had over 200 repos. This was going to be a big challenge for us. I would like to share with you how we brought TypeScript to Snyk, how far did we get, and some of the lessons that we've learned along the way. But before we dive in, let's make sure that we're all on the same page about what is TypeScript. TypeScript is a superset of JavaScript, and that means that 100% of JavaScript is valid TypeScript, and it brings optional static types to the language. Let's take a look at an example. So here we have a function that just reads a file from disk given a path to file. If the file doesn't exist, we're going to throw an error. And if it does, we're going to read back its file contents and return an object with name and text properties. This is what this might look like with types added in. We're saying that the path to file is always a string and that the file content is always a string. We could take this further and we could even type the output of this function using a TypeScript interface. So here we're saying that our object name and text is of interface file where the name and text properties are always a string. TypeScript has a variety of types to help you model all sorts of different situations. I just want to walk through a couple of them. If we keep going with the file reading example, and let's say that we now want to be able to initiate the file read. So we need to provide the path to file, which as before is a string, but we also want to know who initiated the action. So we want to say that if the user clicks something in the UI, then the action creator is the user. For everything else, let's assume that this was an automated action and record the organization. So we could use a union type to help us with this. We could say that type action creator is either a user or an organization. When using union types, only the shared properties within the types of the union can be accessed. So here, if we want to access the initiated by and the group ID, which is shared between the two types, we will be able to do so. However, if we want to be able to access the org ID, for example, we're not going to be able to do that without an error. So we'll have to tell TypeScript which of the types in the union we're working with at the moment. And we can do that by using the as keyword. So we'll say initiated by as organization, and then we can access that. An intersection type allows us to put multiple types into one. So for example, let's say we wanted to be able to validate all of the options that we might pass down to either read or create a file if we can't find one. We might want to separate the options based on the logical operation we're performing, whether it's reading or creating, just to keep things tidy. And we can do that with the intersection type. And we can put the two together when we pass it in through the options. So here we could say that the options are read file options and the create file options together. And this is particularly useful if you are refactoring some code. Perhaps you have a function that is doing too much, and separating the types can really help you understand how to later refactor the code as well. So one of my favorite features is being able to reuse an interface inside another interface. So if we do actually go ahead and create our get or create file function. So now we could try and read the file from disk, given the path to file. And if it doesn't exist, aka the previous function throws, then we could create the new file. But we also want to know that it was actually created, so maybe we could do something with that. So we could model this by creating a file res interface in which we've added the created property, which is a Boolean, and then the file, which is the same interface file that we have already had. TypeScript also allows users to define enums, which are basically named constants. So let's go back to a previous example of reading file from disk. And we can see here that when we're reading the file contents, our fs.read file function takes a path to file, and then it also takes an encoding. Let's make that encoding a parameter to this function. And let's say that we only want to allow two types of encoding. That's base64 and UTF-8. So we could use an enum to represent this. We could say that we have an enum file encoding where the only two allowed strings are base64 and UTF-8. So now that we've added this parameter to the function, TypeScript is actually going to complain about the rest of the call sites where that function is used. And that's because you have created a new argument, which is mandatory, and it will no longer compile. So we can go ahead and fix that up, and we can use our enum here directly and say that in this case, we're going to pass through file encoding UTF-8. So what would happen if we try to pass in something like UTF-16? Well, before you even run any code, TypeScript is actually going to throw an error, either during compilation or in your IDE. And it's going to say that argument of type UTF-16 is not assignable to parameter of type file encoding. And that's super handy. It will go even further. And if this is the only function in your file, it's actually going to tell you that this code is not used at all. So you can go ahead and delete that. TypeScript can also infer the type from the context around it. And whenever you initiate a variable, it can also infer the type from that. So here we are saying that we're going to let created to be false. Therefore, if we try to reassign this afterwards to a different type, like in this case, we're saying that created is 12, we're going to get an error because type 12 is not assignable to type Boolean. So this means that you don't have to be extra verbose with your typings, which is great. And TypeScript also comes with a whole variety of different IDE integrations and features, which are great. So this is signature hints. And let's say here we're using a third-party library called Semver. And as we are typing, we're going to be able to see what are the different functions that are available to us if that library has typings included. And so you'll be able to also see what the parameters that you should be passing are and what shape they are. In all of these examples, I'm using VS Code. After talking about moving to TypeScript in our engineering meetings, we decided that it would be best to jump straight in and choose the repo that would benefit the most from type checking. So we chose our biggest and oldest codebase, which is our main application. And this isn't something that you would normally do when trying out something new, but with so much legacy code that we constantly had to rewrite and refactor, this was going to have the biggest return on our investment. So the initial effort was only about 1 day to create an app that would be a mixture of TypeScript and JavaScript. And to do that, we needed to introduce a very basic TS config with the key property of allow.js set to true. And once this was done, we just converted our rootmost index.js to become an index.ts so we could test the whole setup. And this is what the conversion might look like. So if you have some legacy ES4 like we did, you might be updating all of the vars to const, and you might be updating your imports. But overall, it's quite an easy diff. And immediately we saw some things that just would not work for us. Our code wasn't structured in a way that was easy to compile into a single dist directory. So we had to create a root level lib directory and move everything in there. And this was simple enough, but unfortunately it did generate a huge diff in our Git history. So it was harder to see the history of the commits. But once this was done, we decided to continue. And as we started running the tests, and this is where, boom, we've realized that our testing tool at the time, Tap, doesn't actually support TypeScript. So this was maybe a year and a half, almost 2 years ago now. And this wasn't great. And it meant that we had to basically create our own fork of Tap and use TS Node in order to run our tests. This wasn't such a big deal. And overall, it did only add a little bit of extra time to our 1-day estimate. So we were ready to continue. So things were looking good now. And by the time the tests have finished running and we were done with all of the changes, it was quite late on a Friday afternoon. It was almost 8 p.m. But we have a culture of kind of merging it in once it's green. So we went ahead and merged it anyway. And things were looking good. Nobody got paged. There were no incidents over the weekend. And we were quite happy. But unfortunately, early Monday morning, we came in and we were horrified to find that incremental compilation was taking 10 to 14 seconds. And that really sucks. After doing a little bit of digging, we found that ECMAScript 2015, just like TypeScript, considers any file with a top-level export and import to be a module, and otherwise it is a script on the global scope. And that means that it actually completely invalidates the build cache. So the fix for this one wasn't going to be easy. We either had to go full on TypeScript or at least full on ES modules, which meant that we all had to understand and learn how to convert this. So we needed to go from something that looks like this to something that looks like this. And most of the time, this is simple enough. And we did spend our first day just converting as many as we could to try and reduce down the compilation time. But because we have legacy code, we also had a whole bunch of code that looks like this. So what would you do with that? This is not easy to convert. You have to actually refactor this away. So now everything was finished. And the next steps would be to continue rolling out TypeScript to the rest of our 200 repos. So we needed a few simple guidelines to help us get there and to do so gradually. We settled on just a couple of simple rules that we would all follow. And I would like to touch a bit more on each one in a second. We're saying that we want to convert all of our templates to TypeScript. All new repos are TypeScript, and we want to convert any existing ones as we go. All new files are to be TypeScript and convert any existing ones as you go. And we want to keep track of the progress that we're making. So if you have any templates at all, convert those up really early on and make sure that this is your ideal repository so that you can have TypeScript from the get-go, but you can also use this as an opportunity to switch out any tools that you might want. And we actually used it to move away from Tap to Jest. And also to introduce Prettier and some other updates. And once you have this in place, it's going to be really easy to make sure that all new repos are indeed TypeScript. However, for any existing repos, it was going to be more involved. So we agreed that while we are planning for our next feature, we would incorporate a little bit of extra time into each estimation so that we could convert the repository to TypeScript and then add our code on top. And this might sound like a lot more work up front, but overall, this has actually helped us to move faster. Once you convert something to TypeScript, it's actually easier to write code in there, and spotting mistakes becomes much simpler as well. And this, in fact, has worked so well for us that this is now our sort of default go-to action on the team. We always add refactoring first before adding the next feature or a fix. And once you've done that, that means that you can do what we've done for the main app, convert just the bare minimum to TypeScript and enable allow.js. And on our team, we're really, really into incremental delivery. And so that meant that we were trying to make sure that everything we were adding was a small incremental PR. And that meant that we could take the conversion as far as we could afford and then come back to it later and keep improving. So everything would be an individual PR. For example, the conversion to bare minimum and adding TypeScript would be one very small pull request. And it might just look something like this, where you've added TypeScript, you've maybe changed some scripts, and you've added the build step. And then after that, you might, next time you're in that area of code, convert all of the existing files very quickly to TypeScript and just update whatever is the bare minimum, which usually happens to be the import statements and getting rid of vars. But we also took this as an opportunity to remove any .then promise chains because we really wanted to move to async await. So again, the diff that this generates is quite easy to review, and generally there was no hard refactoring of the code. And once you've got this, it's basically rinse and repeat. So every time you're in that area, do a little bit more, do a little bit more. Ideally, add some types for your key data structures and your key functions early on as well. But even if you don't, you're going to benefit from type inference. So similar for all new files, we would make sure that any new file that gets added is always .ts, and we would enforce this during code review. And you would convert any existing ones as you go along. And the same goes for any tests that are attached to whatever feature you're working with. This one was quite important for us. We wanted to treat this like we would any other feature, and we wanted to be able to see the progress we're making. And this was really helpful because you could at least picture the end in sight, and you might even have an idea of at what date you might be finished. So we wrote a little script, and for a while we were posting every week how many % more TypeScript we were. And this was really great and really motivational. And it actually even sparked a little bit of friendly competition between the individuals and the teams, because every week you wanted to go a little bit further. It was quite a simple script. We were just basically trying to see what was the difference in that repo between TypeScript code and JavaScript code. But we also used this script to count how many .then promise chains we had in place, because we were also removing those as we go. And quite recently, maybe just a couple of months ago, we were actually finally able to remove allow.js property from our TS config, which is absolutely great. So that means that we've completed the migration in our main application. So it's been just over 1.5 years now. How far did we get? And what did we learn? So overall, out of 200 repos, 71 are 100% TypeScript. So overall, we're about 65% TypeScript. The rest of the repos, for some reason, did not need to be touched in that space of time, and therefore not even sure if it's worth it now, because if there is nothing that we've gone back in there to fix, is it worth throwing the effort now to go and just add TypeScript? Our main application is 100% TypeScript now. However, when you factor in the tests, it's only about 65. And again, some of the tests haven't had a chance to be updated at all, as we didn't need to touch them. So we might need to have some dedicated effort to just go in and finish those off. And our second main code base, which is our CLI, is now 90% TypeScript, 80% if you include the tests. As soon as you convert even one file to TypeScript, you're going to get immediate benefits. You're immediately going to be able to spot unused variables, unused functions. You're going to spot function calls where the parameters are the wrong shape, they are in the wrong order, there isn't enough of them. You're going to see tests where you're mocking the boundaries incorrectly, where the data structures are not right. This is really, really eye-opening. And it was a little bit shocking how much you could find by just enabling TypeScript. But the most dangerous mistakes were the ones where you believed the code did something that it in fact did not. So let me share just a few examples of what I mean here. Let's say for some reason we want to calculate a bill tip after we've been out in the restaurant. Alice comes along and she sees that this is how we use this function. We're calling calculate bill tip with an amount and then the country code. However, quite a while ago, Bob has refactored this function and didn't update all the call sites. JavaScript isn't going to yell at you and pick this up. So Alice believes that the country code is important in this calculation and is surprised when she finds weird results that the amount she gets back doesn't change no matter what country she puts through. So the understanding of the code changes. You believe that the country code is important and you might be building other features on top of this that rely on this, when in fact it is not. And this one I call, you wanted a cat, but you got one without a tail. And you might be wondering, what am I on about? So let me explain. Let's say we have a main application, and we also have a microservice, and it is our cat service, and it has the cat API. So maybe a cat extends an animal, and the cat adds tail, whiskers, some cat meta, and the cat meta just tells us a little bit more about your furry pet, favorite snack, given name, and whether the cat is vaccinated or not. And the animal has some basic properties like ears, eyes, paws, coloring, and the allowed colors are ginger, mixed, and black. So let's get our request together to generate a new cat. So the cat request body needs to look like this. We are passing through cat meta and then some cat settings, in particularly the color. So let's say we want to create a pet with the name Fluffy and the color brown. But actually, TypeScript is going to tell us that brown is not one of the allowed colors. So let's quickly fix that up and change that to ginger. Okay, so our request is ready. Let's see what's going on the other side. So when our request comes into the cat service, we are just going to take that through and generate some cat data and return that. So what would happen if we shared the cat type across from the main application to our cat service? Let's do that now. Okay, so now we're saying that this is returning a cat. And immediately TypeScript is going to tell us that actually the property tail is missing in this type. So while you believed you were generating cute cats, you were actually creating little tailless monsters. With TypeScript, mistakes like this are much easier to spot. You can start sharing types between the services. You can start noticing when things have changed. Refactoring becomes much easier. If you are able to type the input and the output to the function, it is much simpler to refactor whatever is in between. You could use types to help you mock the boundaries between your services. It also helps you think about the wider context. You're not able to just add a type just in the context that you're working in. If anywhere else is using that type, you will have to zoom out and think about what are all the different uses and properties that this data structure might have and pick up along the way, because you will have to model them all together before you get your app to compile. So this leads to better understanding of the code, better thinking about future features you might add. And it also means that you can start thinking about how you could improve your architecture once your understanding of your code has improved over time. Overall, our code base has never been in a better shape, and I actually cannot imagine not using TypeScript anymore. Thank you.
Thank you, Lili. So let's see if we have questions for you. Before that, I want to apologize because it seems that we have a small issue in the start of your talk. So the very beginning was not streaming live, so people have not seen it seems. But hopefully it will be available later offline for those who didn't see the very beginning of the talk.
Okay.
So everyone, you can ask questions on the YouTube channel, or you can ask questions on Slack as well. So we have a question for you from Brian, who is asking, after the incident with merging the initial TypeScript code, are you still merging when it is green, even on Friday?
Yes, actually, yes. So we don't see this as we shouldn't be merging on a Friday. We see it as we should improve our testing and understanding of the feature before pushing it. So instead, it's pushing us to check better before merging next time.
Let's see if we have additional questions. So someone is asking if we will publish the slides. The talks will be all available offline in the G-Nation channel. So if you want to see the full presentation later, you can come back. Probably in a few hours, it will be already available to you. Okay, another question on Slack. How do you handle plan upgrades of TypeScript? There are interesting TypeScript releases from time to time. How do you handle / plan upgrades of TypeScript?
Generally, we kind of just bump it as it shows up. It does sometimes mean that you might be biting off more than you thought, where you might have to run through and update quite a few things. But so far, they haven't been like big, huge things that would block you. It was mostly been little tweaks that you have to do. So it hasn't been an issue.
Let's see. Everyone, do you have that is a question from me. Do you have to change your linting configuration a lot of time, or it's still quite stable between different TypeScript versions?
So those are usually the little niggly things that you might have to run through and format. But no, we haven't really changed our configuration. With time, as we're using TypeScript more, we kind of become and tighten up the rules and get a little bit more restricted. So over time, we're hoping to get more and more restricted. But apart from that, we haven't had to do huge changes. You can match your existing rules when you convert to TypeScript so that you have an absolutely minimum diff.
Okay, let's see if we have another question. Let's wait for a couple of seconds. Do anyone have another question for Lili? Okay, it seems that we have. Brian is asking, was the transition to TypeScript hard to get adopted by the teams?
Every team went at a slightly different pace. So I think anyone that has tried it early on was able to see the immense benefit and therefore encouraged everyone else during code review to do the same. So it really helped that we had kind of those baseline sort of rules where we would say that during code review, you are going to say, hey, how about converting this to TypeScript? What about adding a type here? And then that also means that you kind of control a little bit adding TypeScript at every PR. So we avoid merging pull requests if you haven't actually done a bit of legwork and added TypeScript in.
Okay. So we don't have any other question. So I think this is it. Thank you, Lili, very much for your talk. It was amazing. Hope to see you again very soon.
Thank you.
And thank you, everyone that has stayed with us until now. We will do a short break and come back at 11 in the West time zone. So thank you very much. See you.